Hello everyone. Before we dive into today's topic, we want to take a moment to thank you for your support. Every like, comment, and subscription really makes a difference and helps this channel grow. If you enjoy our content and don't want to miss the next videos, subscribe to the channel and turn on the notification bell to receive all updates. There is an experiment that should not exist. An experiment so simple that anyone could replicate it with just a few tools in a school laboratory. And yet, it is also one of the most puzzling experiments ever conceived. An experiment that has opened a breach in the way we conceive of reality itself. One that forces us to question what it means to be, to observe, to exist. Welcome to the deepest enigma of modern physics, the double-slit experiment. If you think science has already explained everything, this experiment will make you think again. If you believe the world consists of objects that exist independently of us, you may have to change your mind. If you think that the simple act of observing cannot change reality, get ready for a surprise. To understand what we are talking about, let's start from the beginning. Imagine a wall with two thin vertical slits. Imagine projecting a light source toward it. Behind the wall, a simple white screen capable of recording where the light arrives. What would we expect to see? If we thought of light as made up of particles, small balls traveling in a straight line, we would expect to see two bright bands on the screen, each corresponding to one of the slits. But what we actually observe is quite different. A complex pattern appears on the screen, alternating bands of light and darkness, an interference pattern. This pattern cannot be explained if we imagine light as composed of particles. It is the typical signature of a wave phenomenon. When two waves overlap, they can either add together, creating bright light, or cancel each other out, creating dark areas. In 1801, physicist Thomas Young first demonstrated this behavior, and from then on it seemed clear. Light is a wave. But the story took an unexpected turn. In the 20th century, thanks to the work of Einstein and Planck, we discovered that light is made of discrete quanta of energy, photons. And these photons, apparently, can behave both as particles and as waves. So far, so strange. But the true mystery emerged when scientists decided to shoot the photons one at a time. Now, let's think logically. If I shoot one photon at a time, it cannot interfere with other photons. We would therefore expect a single spot to appear on the screen, right behind one of the slits. And yet, patiently allowing the photons to accumulate one by one, the interference pattern forms once again on the screen. It was as if each photon, on its own, passed through both slits simultaneously. As if it interfered with itself. How can a single particle behave like a wave spreading through two openings at once? The enigma deepens further. Scientists then tried repeating the experiment with other particles, electrons. These are particles with mass, electric charge, fundamental components of matter. Even electrons, shot one at a time, form an interference pattern. Just like light. As if that weren't enough, the experiment has been repeated with neutrons, entire atoms, and even giant molecules composed of hundreds of atoms. Always with the same incredible result. But the real twist came with a simple idea. Let's observe which slit each particle passes through. A detector was introduced. And at that point, the impossible happened. As soon as one tries to observe which slit the particle goes through, its behavior changes. The interference pattern disappears. Simple bands appear on the screen, just as we would expect if the particles were little balls passing through one slit or the other. In other words, the mere act of observing changes the behavior of the particles. When we do not observe, each particle seems to exist in a state of superposition, a wave of probability exploring all possibilities simultaneously. When we observe, we force the particle to choose a defined behavior, as if our act of observation collapses the infinite possibilities into a single concrete reality. It is such a radical phenomenon that even Einstein could not accept it. God does not play dice with the universe, he said. But later experiments, including those related to Bell's inequalities, confirmed no classical hidden variables can explain these results. Quantum mechanics describes reality not as a collection of objects with defined properties, but as a network of possibilities that materialize only at the moment they are observed. Until we observe, a particle does not have a defined trajectory. It is not here or there. It has not passed through this slit or that slit. It is everywhere and nowhere. Only when we interact with it does the quantum system collapse, and we see a concrete result. Does this mean the observer influences the observed? In a sense, yes, but not through a mental or magical intervention. It is the very act of interacting with the system, regardless of the instrument used to observe, that alters its evolution. And here the boundary between physics and philosophy becomes thin. What is reality, if it depends on how we choose to measure it? Does a world, out there, exist independently of us? Or is the universe as we know it the product of a continuous process of interaction between our act of observing and the possibilities that nature offers us? These questions remain open. And there's more. No one has ever found a limit to this behavior. There is no precise boundary between the quantum world and the macroscopic world. In theory, even very large objects could exist in states of superposition. It's just that in practice, through interactions with the environment, these states collapse almost instantly. This phenomenon is called decoherence. But in principle, the entire universe could obey these same rules. Our experience of a solid and concrete world may be nothing more than an appearance, emerging from a much more fluid and uncertain quantum background. And so, an experiment so simple, 2 slits, a screen, and particles launched one by one, continues to challenge us after more than 2 centuries. It teaches us that reality is not a stage where events unfold independently of us. It is a web of possibilities that materialize through the way we interact with them. It reminds us that the world is far more mysterious than it seems. And it invites us to look at the cosmos not as a predictable mechanism, but as an infinite sea of possibilities. Possibilities that, in some still inexplicable way, seem to await someone to observe them in order to take shape. Welcome to the endless mystery of the double-slit experiment. And prepare to see reality with new eyes.